Thank you very much for coming here and attending this talk about an open source implementation of the operational transform in Python. Its author is Dion Misic. He's a student at, let me find, it's called Gungahlin College in Canberra. And he started learning Python as his first programming language in year 11, so about a year ago. That's what a year of working gets you. So please welcome Dion.
Thank you. So hi everyone, my name is Dion Misic, as he just said, and this is my project, Wordsmiths, a project which is highlighting operational transformation, an algorithm made popular by Google Docs and their collaborative sharing system. I personally started studying this a multitude of weeks ago, about 10 weeks maybe. So operational transformation is an algorithm which is hidden behind a lot of academic papers and corporate walls. It's quite difficult to find a lot of information about it, so this is my experience with it and what I learnt when I was studying it. And my slide isn't changing. Okay, sorry about that. So before we get into this talk, I just want to quickly give you some background on myself. My name is Dion Misic. I'm in year 12 at Gungahlin College in the ACT Canberra. I've had about 1.5 years of experience in programming, and Python was my first language. During this time, I grew a passion for web design and web development, and have ever since been developing using Python and Flask. So essentially, one of the tasks I received at school was to study an algorithm and research it and try to implement it myself. I was intrigued by how Google Docs did their user collaboration with multiple users over a high latency environment, such as the web. So I decided I'd try and research what made this collaboration possible. The algorithm I came across was operational transformation. There were a couple of other ones which I did come across, but operational transformation was the one Google uses and was the popular choice. And so I set out to learn as much about it as I could and research it. The issue, as I mentioned earlier, was there was a limited amount of documentation on the algorithm. If there was any documentation, it was hidden behind student papers or behind corporate walls of identities such as Google, which are all quite cumbersome to understand, especially when you've got limited experience like myself. So that brings me to the purpose of this project and the purpose of making it open source. It is to raise awareness on operational transformation, and it's so others who are interested in the project like me can learn, improve, and study the algorithm of operational transformation. You can read about the project on my GitHub repository up there. You can also demo it. There's a live demo up at www.wordsmiths.io. And you can play around with some of the features and demos which I'm going to be showing in the presentation. So the role of the algorithm is to keep 2 or more users in sync on a document in real time. Most people think if you just open a connection between 2 users on a document, and if you just let them edit, it'll all work perfectly fine. I'll show you why this isn't the case and why this fancy algorithm is required to keep 2 people in sync. So imagine a world where 2 users can connect to a text document and they work in a shared document space. All users can do 2 primitive operations, an insert operation, which inserts a character at a given position, and a delete operation, which deletes a range of characters defined by range. Now, don't discard the other operations that you can do in a text document sort of environment. So things like changing styles, formatting text. But for this example, just discard them for the sake of simplicity. I'm going to try to illustrate the problem which happens using some diagrams. So imagine a state in which 2 documents are at a state of ABC, with ABC at positions 0, 1, and 2 of the document respectively. Imagine the 2 users try to insert characters on the document. So user 1 tries to insert the characters XX at position 1, and user 2 tries to insert the characters YY at position 3. They both apply this locally, and they end up at 2 states, as shown. Once their operations get sent to the server so that they can be applied by the other user, you can see the issue that occurs. They both try to do it naively, and they don't change the operation, and they end up in a state where they're both unsynchronized, where they should be synchronized. So that's why operational transformation exists, to fix this problem. So we have to do something to the operations when they're sent to the server so that they don't end up in an unsynchronized state. This diagram presented on the screen is known as the OT diamond problem. Essentially, the 0 at the top represents a state at which they are both in sync. The two branches coming from this state, A and B, are the two user operations. So user 1's operation is A, user 2's operation is B. Once they hit this middle point, they hit the server and they transform against each other to derive two new operations, B prime and A prime, which can be both applied to reach another shared state, which is the 1. For those that are more mathematically inclined, there's Google's definition of the algorithm, which states that if you transform any two operations, A and B, you receive two new operations, A prime and B prime, where B prime times A is equal to A prime times B. It's a bit confusing at first glance, but pretty much it just means that you've got your first operations, they get transformed, and then you can apply the second operations to get to a shared state. My implementation is essentially split into two parts, and I'm going to be demoing two parts of it today. Currently, and the first part of it is my library. So you can install my library using pip install Wordsmiths, and you can read about it on the GitHub page. It's a basic transformation library that supports string and character transformations. As you can see there, those are the two classes that come with the library, one for strings and one for characters. They both have a method, which is the transform method, which does the exact functions which I mentioned earlier. Here's just a basic look at what it looks like to use the library. It's just a basic import. You instantiate it to a variable and then perform the method on the operations. So essentially, the way the library works is the algorithm defines the relationship between the two operations. In this sample space of insert and delete operations, there are 4 possible outcomes that you can have, which is insert, 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 delete, delete, insert, and delete, delete. It then uses conditional statements to check the differences between the two operations and then create 2 new operations using those conditions. Here's an example of the implementation at work. I've set up a basic web page which takes 2 user operations. You can define what the operation type is, if it's an insert or a delete operation. And then you define the index and string, and then hit the transform button to see what happens. As you can see, the document starts at the bottom with ABC on both users, and they both try to insert characters like in the previous example. But you'll see that the operational transformation library gets it to a point where it is synchronized. Again, I want to plug in that if you want to play around with the demo, you can find it on the live website at www.wordsmiths.io. If you want to play around and try to break it, it's available there. Okay, so the second part of my implementation is actually trying to create a place where multiple users can share on a document. Now, it's quite an ambitious goal, to say the least, but it's still something that I'm working towards, and it's currently incomplete. But I thought I'd present my design strategy and what I've got completed up to now. So essentially, the design strategy is to have a client-server relationship where any number of clients can connect to the server using WebSockets so that the client and the server can speak freely between each other. The client has the purpose of sending operations to the server, where the server compresses the operations and then transforms them together. It also saves the said operations in the document history, so that there's a document history which is global to all of its users. And then the clients will have their own versions of the document. This is similar to something you would see Google do, and I'm pretty sure this is how they implement theirs. But then again, I'm not 100% sure because the documentation isn't very available. So as I said earlier, I haven't completed the entire strategy. However, I do have some live testing stuff available on the live site. The site has 2 features. the algorithm showcase, which I was showing you guys earlier, and then a quick socket showcase. The website is hosted on a virtual private server using Nginx as a load balancer and reverse proxy, and then Gunicorn as an eventlet web server to allow for sockets. The site has basic user authentication features, letting users register, log in, and I do stress that if you do create an account on the website, use a different password because I haven't really implemented much encryption besides standard Python libraries. But yeah, it's just really a play around sort of thing. So once users log in, they're presented with a dashboard that looks like this. You can look at all your books, all your shared books, and then you can view a actual edit mode. When two users are on a same shared document, which you can add by using the Add Friend button, they connect through sockets using flasksocket.io. It's a library which allows for the WebSocket protocol to work. And then, yeah, the two users can edit at the same time. Now, this isn't a very good example of what's going on. It's really just showing off that you can, in real time, edit. But you'll see quickly, if you do test it yourselves, that it does break quite quickly, and you'll see that they do come out of sync really fast. So again, I'm trying to make sure that I am learning how to implement the algorithm I mentioned earlier to stop that from happening. Yeah, so essentially the goal is to get that last algorithm that I was showing you and plug it into this to create a sharing system. So how has Python impacted my project? Python's simple nature has made it very easy to document the project because the syntax is very easy for people to read. It allows people with little knowledge to be able to understand it at a glance, especially for people that are students like me, where I might only have a 1.5 years experience, but since Python is so easy to read, it's easy for people like us to quickly pick it up and then start to learn it. It allows us to ignore all the quirks of the language and the syntax and explore more complex programming theories. Python has made the process of web applications and protocols more simple and easy for me to learn. It makes things easier to understand because I can use libraries such as Flask and flasksocket.io to quickly support web protocols and not have to go into intensive research on how to implement them. Also, considering operational transformation is a lot of moving around of data types, especially dictionaries and lists. User-friendly data types that Python has makes it easy to move around and change data without having to go into really cumbersome details like you would in a different language. Now, even though this is a Python conference and I should really be talking up the language and how awesome it is, I should probably talk about the less awesome parts. You'll notice the list is quite small though, so I've been kind of nice. So the main issue I found with using Python for this project is that a lot of the socket information and the resources for sockets are catered specifically for Node.js and JavaScript. It's not a problem because I was able to find some Python stuff, but it just makes it somewhat harder for people to implement stuff using Python than it would be using a solution such as Node.js. Also, following the theme of comparing it with Node, Node is completely written in JavaScript, meaning it's one language being used universally by the front end and the back end, which isn't always a bad thing, a good thing, but it's just something that it has over Python, and having to use multiple languages can be quite a struggle. In the future, I've got some quite big future aspirations of where I want the project to go and the direction it's heading in. Essentially, I want to get the active open source community to work on the project, to create a place where operational transformation can be learned about, it can be improved on, discussed, rather than being hidden behind academic papers and corporate walls. And that's mainly the main idea of this project. It's to make this algorithm easier to understand. And it's more to get the algorithm improved rather than just keeping it at a stagnant place and then having it only behind Google's usage. I remember when I first started researching the algorithm, I came across only one implementation on the web that I could find written in JavaScript. And when I tried to actually use the implementation, there wasn't even enough docs to actually use it, so it was pretty useless. So pretty much that's where I want this project to get to a place where I can actually show it to other people, and they can plug it in and use it and then learn from it. Also, I want to get to a position where I can look into operational transformation and how it works in other locations, not just the confines of a document. So if you might have seen Google presentations or Google spreadsheets, they also use operational transformation outside the confines of a document. So yeah, I want to find a place where we can learn about how it can be used in other environments. Before I open the floor to any questions, if this project has interested you, I do really encourage you look at the documentation and help contribute to the project. Any work is more than valued, and I'd like to thank everyone at PyCon Australia for giving me this opportunity to speak today.
So we have about 10 minutes for questions, but I'd like to remind you to keep them brief, and please keep them questions.
Have you seen any documentation or research into doing this, but with peer-to-peer?
What do you mean by peer-to-peer?
Without the use of a server?
I haven't actually looked into any of that, really. I was mainly, as I saw operational transformation, I sort of had my heart set on seeing how that works because it's how Google did it, and I was really interested in how they did it. I'm sure there is a way that has been suggested, but I haven't really looked at it in great detail.
Hi, thanks for the talk. It's really good. You spoke about what the algorithm does. Maybe just at a high-level overview, how does the algorithm actually work in keeping things in sync? How does it do the transformations between the operations?
Yep, so it uses conditional statements. So like I was saying earlier, it was a pretty high-level overview, like you said. It pretty much figures out if it's an insert or a delete operation, and it finds out what they are. And then it uses a conditional statement to check that. And then there are some more conditional statements based on that relationship that they carry out. And so, for example, if it's an insert-insert relationship, it could, I don't know how to really explain this, it's quite difficult, but one of the conditions could be to increase or increment the index by 1 or by 2 or by the length of the text, depending on the relationship again. If you want to look at the documentation on GitHub as well, you can look into the exact way it works and the exact conditions which it has.
What happened when both users inserted the same index and like probably the same time? What would happen to the transformation?
Yep, so the algorithm demo, which I had before, inserts them at the same time. So if you want to actually test it out, feel free to. I could even pull it up now if you really wanted. I'm not a, sorry? At the same index, yeah. So you can test it in the demo as well. I don't have the answer on me right now, but it should work. It unsynchronizes them, really. That's awkward.
That's live bug reports.
Thanks. You've learnt Python really quickly as a young guy. Can you give us briefly how you went about it, what tools you used, or where you learned it from?
So I pretty much came to school and I didn't really know what I was doing, so I picked a bunch of classes I didn't really enjoy, and then I moved into IT. My teacher's actually in the crowd, somewhere there. Yeah, but I learned most of my Python from Grok Learning at the start, so that gave me my fundamentals and introduction to how programming works. And then, yeah, it was really just classwork and learning from passion as well on top of that. But yeah, Grok Learning was really the fundamental part of it.
Got a question about the bandwidth overhead, because it sounds like there's a lot of back and forth going of transformations, that the data that I did, and then sending back the same thing a lot of the time. So is it essentially just a twice the bandwidth of whatever it is you're editing, or can it actually be optimized beyond that?
That's a great question. Well, since it uses WebSockets, the overhead is less than it would be if I was doing AJAX requests or doing stuff like that. So the WebSockets does help with that. I'm sure there is a better way to optimize the speed and which operations I'm sending back. but I'm not 100% sure and I haven't really looked into actually optimizing the algorithm. I was more looking into understanding it and making it easier to understand.
I think that's it. Thank you very much.
Thank you.